How do ionic salts in solution react to form precipitates? Remember, a precipitate is a solid that comes out of the solution. What happened in the precipitation reaction? Well, lead nitrate salt was dissolved in water, and you added either sodium iodide or potassium iodide into the water. The two solutions were mixed, and solid yellow lead iodide precipitated out of the solution, and what was left behind was a solution of sodium nitrate. Lead nitrate and sodium iodide break up into ions in water, as you recently learned in the conductivity lab. You can see here the lead nitrate breaking up into lead ions with a +2 charge and nitrate ions with a -1 charge. You can see the water as little green blobs separating them. Then the sodium iodide breaks up in water into sodium ions, Na+, and iodide ions, I-. When we mix them together, the iodide bumps into the lead ions rather rapidly. The water molecules, in this case, don't have enough energy to break the lead iodide apart. That means the lead iodide is pretty strongly bound together. And we get larger and larger clumps of lead iodide units stuck together, and ultimately, actually rather quickly, we can see those lead iodide units because they're reflecting yellow light. We call the clumps of solid lead iodide a precipitate. Let's look at the ionic equation for this reaction. We can show the ions reacting on paper. It's called an ionic equation. As you can see, there's a lot of ions reacting or not reacting. The sodium ions and the iodide ions, that's one of the reactants solutions. And then the lead ions and the nitrate ions, that's another solution. They form the lead iodide, PbI2, and there are sodium ions and nitrate ions left over. We can say sodium iodide solution reacts with lead nitrate solution to form solid lead iodide and sodium nitrate solution. But sodium ions and nitrate ions are appearing on both sides in the solution. Seems like an awful waste of ink. They're not really involved in the reaction. They're kind of like the folks who watch the football game from the stands. We call them, therefore, spectator ions. They are not participating in the reaction. That gives us the opportunity to write what we call a net ionic equation, which will be very important as you continue in your studies of chemistry. We simply eliminate the spectators. The only thing we show is the action on the field. We call this a net ionic equation because it only shows the ions that are involved in the reaction. In this case, the net ionic equation shows two iodide ions reacting with a lead ion to form solid lead iodide. Remember, all chemists are kind of lazy. That means we tend towards the low energy state. So we don't like to waste energy, and we don't like to write things that we don't need to. Now let's see if there are any regularities in the precipitation reactions of group 2. Group 2, beryllium through barium. We can add 4 different anions or negative ions to the chloride of each ion. This is actually an experiment that we do. And that experiment will then be the next thing that you do in order to study the reactions of group 2 cations.